Is the Big Apple getting a little too heavy for its own good? A recent study revealed that New York City is sinking. And get this, it's all because of those towering skyscrapers. Apparently, the whole event is called subsidence, which is when the Earth's surface settles bit by bit, or suddenly sinks. Soft sediments shifting and the weight of the city itself are the culprits behind this sinking sensation. Now, don't get too alarmed. The study found that New York is sinking at a rate of 0.04 to 0.07 inches per year. Sure, that doesn't sound like much, but there are parts of the city that are sinking even faster than that. This sinking situation could cause some trouble for the city, especially since it's already pretty low-lying and home to over 8 million people. So it's important that local authorities come up with some strategies to tackle the growing flood risk and rising sea levels. Although, I'm not sure building giant seawalls is the way to go. We might need to get a little more creative than that. Geologists want to make sure we're all aware that building more high-rises near the coast, rivers, or lakes could contribute to future flood risks. So we really need to think twice before we start constructing skyscrapers left and right. In recent studies, scientists calculated the total mass of all the buildings in New York City, over 1 million of them, and it adds up to a whopping 1.68 trillion pounds. Talk about a heavy load. Now, they didn't include the weight of the roads, sidewalks, bridges, and other paved areas, so you can only imagine how much more weight is added to the city. But hey, even with these limitations, the researchers did a pretty good job of accounting for the complex geology beneath New York, including the sand, silt, clay deposits, and good old bedrock. They found out that certain types of soil, like clay and artificial fill, are more prone to subsidence. On the other hand, bedrock stays pretty firm and keeps those skyscrapers in place. So at least we don't have to worry about the Empire State Building taking a dive anytime soon. Comparing their fancy models with satellite data, the researchers created a map of the city showing where the sinking is happening. And guess what? The increased urbanization and all that groundwater pumping and draining are only making things worse. It's high time we start protecting our resources, don't you think? I wouldn't start packing my bags just yet. New York isn't the only sinking city out there, you know. Jakarta, the capital of Indonesia, is facing some serious sinking action too. In fact, parts of it could be underwater by 2050. That's like a real-life Atlantis situation. Over 30 million people in Jakarta are now deciding if they should relocate the entire city. If there's a city out there we should worry about sinking, that's Venice for sure. But why is it so eager to take a dive, you might ask? Well, let me tell you the complex truth. You see, Venice decided to set up shop on a marshy lagoon with shoddy foundations. As time went by, the ground underneath just couldn't hold it together and started compacting like a squished marshmallow. On top of that, the city's been slurping up groundwater like it's going out of style or something. The cherry on top of this mushy cake is that the sea levels have also been slowly rising. And guess what? Those sneaky plate tectonics are having a laugh by shoving the Adriatic plate under the Apennine Mountains, giving Venice an extra push downward. Someone had the bright idea to stop pumping groundwater, thinking they could stop the sinking shenanigans. But hold your gondolas. A new study revealed that the sinking hasn't completely stopped, just slowed down a bit. It turns out the whole area is tilting ever so slightly to the east, with Venice perched on the slightly higher end. You must be wondering how much Venice sinks in a year, right? Brace yourself for this shocking revelation. It's sinking at a rate of about 0.04 to 0.07 inches a year, similar to New York. At this pace, in the next 20 years, it could sink a whopping 3 inches below sea level. To avoid turning into a Venetian fishbowl, locals are frantically building special barriers to keep the water from crashing into the lagoon. But don't hold your breath, because this project has had more delays than you'd expect. Oh, and have you noticed that charming old-style vibe in Venice? It's not just because they're fans of the vintage look. Those salty waters have been wreaking havoc on the buildings, thanks to the water levels constantly breaching the original damp-proofing. Now the water's cozying up to the masonry, and the ground floors of many apartments are no longer safe enough to live in. Now, when will Venice take a dive into the abyss? It's hard to say for sure. Subsidence and rising sea levels are as slow and unpredictable as a turtle in a marathon. But experts have playfully warned that if things continue as they are, Venice could be doing the backstroke beneath the waves by 2100. Fear not, though. They're doing their best to protect this floating gem of history and culture from becoming a Hollywood disaster flick. So don't cancel that Venice day trip just yet. New Orleans has a peculiar watery situation going on too. You see, this lively place was initially built just a smidge above sea level, and now it's gradually sinking. Back in the day, when an area of the city called the French Quarter was just popping up, folks had to make do with what they had. They scored the best land they could find, but it was only about 10 feet above sea level. And let's not forget, the rest of the city is as flat as a pancake, with the areas around the French Quarter being just a hair lower. Now, even though they knew they were up against some soggy odds, the resourceful New Orleans residents did their best to elevate their houses above the flood-prone land they chose as their home. There's more. The ground beneath New Orleans is as wobbly as a plate of Jell-O. Architects had to keep things short and sweet because they feared the soil couldn't handle the weight of taller structures. They played it safe, sticking to 2 or 2.5 stories. Here's where it gets interesting. The city installed a fancy drainage system in the 1900s, thinking it would solve their water woes. And while it did help with the marshes and all, it inadvertently sucked the life out of the soil. Yep, the ground was left high and dry, without enough sediment and water to keep it steady. As a result, those former marshes sank as if they were in a quicksand competition. By the 1930s, things got even more topsy-turvy. 1/3 of the city was below sea level, and by the time Hurricane Katrina made its grand entrance, that number skyrocketed to around 50%. Oh, and here's the icing on the cake. Sea levels decided to join the party, rising faster than a helium balloon. So now, not only is New Orleans sinking, but the surrounding area is also at various degrees below sea level. So what can we do about all these sinking cities? Well, for instance, we could manage our water consumption a bit better. We can't just keep sucking groundwater out of the earth like there's no tomorrow. We've got to find new ways to quench our urban centers' thirst. Think about it. We could purify surface waters, or even turn salty seawater into a sweet solution. Of course, we'll need a boatload of energy to make it all work. Speaking of great urban water management, let me tell you about a town in Denmark called Nye. These guys have got it all figured out. They collect rainwater and use it to supply their toilets and washing machines. Talk about resourcefulness. Now that's what I call a splash of genius.
Meet Hula Male, also known as the City of Hope. This nickname makes total sense since this artificial island is part of the Maldives' big plan to avoid being completely submerged in the near future. Hula Male was created by placing sand from the seafloor onto a submerged coral platform, and it worked. This city sits about 6 feet above sea level, which means it's twice as high as the Maldives' capital, Male. While more and more people are moving there to live, the island was also designed to serve as a temporary evacuation site during dangerous storms and typhoons. Seychelles is another gem in the Indian Ocean that's at risk of disappearing. Unfortunately, coastal flooding is becoming a common issue there, especially during spring tides and heavy rainfall. The problem is that their main island, Mahé, hosts about 90% of the country's population. Along the coast, it's only about 6 feet above sea level. Fiji is the third tropical paradise on our list, and it's also a top pick for travelers. But this nation is in a tough spot, since it's located right in the middle of the Pacific Ocean, where huge storms can really turn things into chaos. Take Cyclone Winston. It hit Fiji back in 2016 and ended up costing them over $1 billion in damage. So one thing they're doing to protect themselves is planting mangroves along the coast and preserving the ones that already exist. These trees are awesome since they help reduce wind speed during cyclone emergencies and also combat erosion by trapping sediments. Egypt might be in trouble too. I mean, it's not like the whole country is going to be underwater and we'll only see the tips of the pyramids in a few years. But things could really change for them as coastal cities are facing a serious risk. Take Alexandria, for instance. 45% of its population already lives below sea level. If the city is flooded, not only will everyone have to move, but Egypt in general will suffer a major impact on its fish production. In Europe, one of the most at-risk populations is in the Netherlands, where about half the people live in areas below sea level. In the future, planning a romantic gesture with tulips for your girlfriend could become an impossible mission. The Netherlands is responsible for 2/3 of the world's tulip production. So if fields are taken over by saltwater, it's game over for the blooms. But the good news is that the Dutch have centuries of experience dealing with water, so knowing how to work with storm barriers and seawalls can prevent them from a doomsday scenario. The risks of rising sea levels probably aren't higher anywhere else than here in Tuvalu. This island chain, located halfway between Australia and Hawaii, could be the first state to become uninhabitable. Its stunning land is only about 9 feet above sea level. And just by looking at it on the map, you can see how narrow it is. In fact, the narrowest part in Fongafale is only about 65 feet wide. So even before higher tides become a real problem, the country's limited farmland could be flooded with saltwater. The next country on our list is the Philippines. This archipelago in Southeast Asia boasts some of the most stunning scenery, but it faces the risk of flooding for 2 reasons. First, due to rising sea levels, and second, because of crazy, unpredictable weather. Since 1990, events like cyclones, earthquakes, and tsunamis have cost the country over $20 billion. Have you ever heard of Vanuatu? This chain of islands, spread out between Australia and Fiji, could be flooded soon. Vanuatu was one of the first Pacific nations to relocate an entire community to a safer spot. Back in 2005, residents living in risky coastal areas of the northern island of Tegua moved to higher ground. Next up, the Marshall Islands, a country located in the Central Pacific. Studies show that 40% of the buildings in the capital city, Majuro, could end up underwater in the future. But this country isn't throwing in the towel just yet. They've got a game plan. They are fortifying the infrastructures of their low-lying airport, relocating key buildings to higher ground, and putting up seawalls on rural islands. Heading south, we've got Nauru. This is actually one of the smallest countries in the world, covering just 8.1 square miles. Today, it's home to 10,000 people, but it's on the brink of becoming uninhabitable. Water levels are rising about 3 times faster there than the global average. The Buada Lagoon sparks special concern since it's the only surface freshwater resource, and it's located only 16 feet above sea level. Our next stop in the Pacific Ocean is the Republic of Palau. Rising sea levels are no joke for them either, but protecting their crops, especially taro, is a priority at this moment. About halfway between Hawaii and New Zealand lies Samoa, and this country is dealing with a unique situation. Not only is the volume of water increasing there, but their land is also sinking. You see, a couple of strong earthquakes and tsunamis hit Samoa back in 2009. So as the crust bounces back to its original position, the overall land surface is actually going down. Because of this, their housing and main infrastructure could take a serious hit, especially since all their airports are along the coast. Let's head to Kiribati. This Pacific nation has a big problem with frequent flooding because most of its people and infrastructure are near the coast. Apart from the volcanic island of Banaba, none of Kiribati's land is more than 6.5 feet above the ocean. To tackle this situation and keep their population safe, they had this big idea of making a massive floating platform, kind of like the ones oil companies have. But the problem is that it would cost them a fortune, as the project is estimated to be around $2 billion. If visiting Vietnam is on your bucket list, you better hurry up. The top 10 things to do there mostly involve cruising to jaw-dropping spots like down to Ha Long Bay, also known as the Descending Dragons Bay. But by 2050, the surrounding land over there might be underwater. Another huge problem Vietnam is facing is that the main rice fields are getting salty. And if you're into Vietnamese food, you know how important rice is for them. Right now, they're especially concerned about the Mekong Delta region being vulnerable. After all, this is a highly fertile area responsible for most of Vietnam's agricultural output, with over 50% of it being, rice. This nation is really putting in the effort to adjust to this new reality. They're flushing the rice fields in the Mekong Delta with fresh water to get rid of the saltiness. Our next stop is in the Caribbean Sea. Grenada is an island country, but you may know it as the Island of Spice, since its tropical climate is just perfect for cultivating things like nutmeg, cinnamon, cloves, and ginger. Unfortunately, Grenada and its incredible fertile soil also face an uncertain future of being submerged. Let's talk about the last country on our list, the Solomon Islands. 5 islands in this archipelago have already vanished beneath the waves, and 6 others are submerged by 20%. They include the Nusa Evili Island, which was once a hotspot to go to for a picnic in the early 2000s. Even though the situation is complicated, it's important to note that more than 300 of the islands there are inhabited. One thing about the Solomon Islands is that it seems like they're always in some kind of recovery mode, since the country often gets hit by tropical cyclones and flash floods. Their population is already working hard to save their homes from the rising seas by building stone walls along the coast, planting mangroves, and constructing houses in higher areas. You rub your eyes, trying to make sense of everything. Perfect circular holes in the bottom of the ocean floor off the coast of Big Sur in California. You have no idea how this happened, even though you're a marine biologist who's been practicing it for years. You go through some of the old records and find out that these holes have been around since the 90s. In 1999, a ship-mounted sonar conducted a survey and found 5,200 of these pockmarks, or large holes over 500 square miles, on the ocean floor. They look like moon craters underwater. You contact your team and get the robot ready to go down and explore the scene and bring back a few samples. You and the team drive to the coast and hop on the boat. You're sitting inside controlling the robot with a joystick. Your teammate sets the robot in the water and drives it down. Everything seems normal near the surface, but as the robot goes lower, the pockmarks start appearing. A bunch of boats swift past you, making you lose your balance and focus. The robot turns on the flashlight so you can see better. But as it goes lower, the resolution is less crisp. It almost reaches the bottom, and the holes are smooth and nearly perfect circular shapes. Some of these holes that were visible in the sonar reading measure more than 30 feet across and 15 feet deep. You show the rest of your teammates the images, and they're shocked. The robot continues swimming, but there appear to be more holes all around. Many of them are too small for the scanner to capture from above. These microdepressions are steep and have sort of tails going in a certain direction. It's possible that the currents underwater played a role in their shape. Everywhere the robot swims, there are new holes all around. After a couple of hours, the robot goes back to the boat with some samples. You take them back to the lab and study them. The robot clearly captures images of human trash, but the samples don't indicate anything alarming for now. Despite the fact that 1/3 of the pockets are filled with trash, there's still no explanation of how they were formed. It's late at night and the rest of your team heads back home. You're passing out in the lab, still trying to find some answers. You wake up the next day and while cooking breakfast, you get this idea that maybe these holes are gases venting out, which could be harmful to marine life. You quickly get the robot and sail out to the ocean once more. This time, you didn't even think about calling your teammates. You place the robot in the water and get behind the screen to control it. The robot descends to the bottom of the ocean and does a survey. So far, the holes still seem to be covered with trash. But some of the holes have marine life dwelling inside, like fish and seaweed. After much scanning, it doesn't look like they're producing any bubbles, which means there aren't any gases venting out, but you're determined to find them. After a while, you reach one of those large pockmarks, and the robot starts scanning around. You find some bubbles coming from a source, but the robot can't reach it. It swims around trying to find a spot, but nothing. You bring the robot back to the lab and work on it. You attach some mechanical arms on it that can lift things and move them. You bring the robot back down to the same spot, but the bubbles aren't as frequent as before. You use the arms to move some of the trash and find out that the bubbles are being produced by a group of crabs chilling next to a pile of plastic. Bingo! The bad news is, you still don't have a clue why the microdepressions and pockmarks exist. As you try to control the robot to go back to the surface, an octopus wraps its tentacles around it, pulling the robot down. You struggle with the controls and push it to maximum power, but the suctions of the octopus are too strong to break off. It's a game of tug-of-war with the octopus and your robot. It takes the robot under a pile of trash, thinking it's lunch. But you use the arms to maneuver the robot out and swim back to the surface. You go back to the lab even more confused. The robot has collected more samples for you to study. Your eye is glued to your microscope, trying to figure out what's going on, but nothing. You decide to do a carbon dating test to determine how old these holes are. After a while, you check out the results and are even more stunned than before. They show that the holes are around 400,000 years old, so it's likely that human trash wasn't the cause for all this. You pull many all-nighters trying to figure out the truth. You gather your team once more and hold a small press conference about this. You claim that this may be something we should be extremely worried about, but you still can't tell them more than what you know. With all the brain work put together, you find out that the large pockmarks haven't changed or been active for more than 50,000 years. The newer holes were most likely created by human trash settling in the bottom of the ocean floor. The marine life gathered some of this trash like plastics and discarded fishing gear and created homes for themselves. This is why around 4,500 of the holes are newer and have trash in them. But it still doesn't answer why the holes appeared in the first place. You're back to square one. The only way to see what's really going on is to clear up the trash from underwater and study them. The story makes headlines in the local community and catches the attention of a cleanup crew. You organize a trip to the ocean and begin the extraction of all the trash. Many cleanup boats arrive and everyone drops down a net to collect the trash. You send down the robot once more to make sure the nets are hitting the right spot. As most of the trash is being collected, many marine life animals scramble and try to find a way to escape. Everyone makes sure not to hurt them. After a couple of weeks, all the holes are cleared up from the trash. You do another sonar scan from the surface and can see the holes clearer than before. But you still don't have an answer for this. You do some more research trying to see if any other holes appeared around the world. On the other side of the country is a mysterious blue hole off of Florida's Gulf Coast. You catch the nearest flight to Florida and make an appointment with the scientists in charge of the expedition. Blue holes are underwater sinkholes that open below the seabed. Just like on the surface, the underwater world also has sinkholes. This one is called the Green Banana and is 150 feet below, and the hole is 435 feet deep. You dive with some special gear with the rest of the team to a barren ocean floor, and the hole is right there in front of you, looking like an oasis in the desert. You and the rest of the scientists are surprised by the diverse marine life dwelling within. Some sea turtles swim past you, and even sharks. These ones don't harm humans. Halfway through, you reach a narrow path, which makes it difficult for humans to pass through. But everyone is careful. There are corals, sponges, mollusks around the corner. You collect some samples and go back to the lab. Blue holes in general are richer in nutrients than barren lands and host plenty of unique marine life. They're quite common and don't pose any sort of threat to anyone. After making the connections, you don't think the holes off the coast of California have anything to do with blue holes. The mystery goes on. For hundreds of years, people in the US have reported hearing strange, loud booms. These mysterious sounds are called skyquakes. And yep, it's a real thing. If you've ever heard a loud, distant booming noise that definitely wasn't a thunderstorm or a car engine backfire, congrats, it looks like you've experienced a skyquake yourself. People report them all around the globe, from the US to India and Japan. They go under different names, and we still don't know why exactly they happen. Sometimes these booms come together with earthquakes. People heard them during the New Madrid earthquakes in the early 19th century and up until January 2020. Those who've experienced them describe skyquakes as a rushing or rolling noise. Famous American writer James Fenimore Cooper described it more poetically as the lake speaking to the surrounding hills, which send back the echoes of its voice in accurate reply. Sometimes these mysterious booms happen in cold weather instead of during earthquakes. One of the skyquake hotspots is near Lake Seneca in New York. They call them the Seneca Guns. The booms can be so loud that they shake windows and doors. Back in August 1886, after an earthquake in Charleston, people heard these noises for several weeks, happening at the same time as many aftershocks from the earthquake. In 2020, scientists from the University of North Carolina looked at old news pieces, especially from North Carolina, where people have often reported these sounds. They hoped to match the noises with earthquakes data, but they didn't find any link between the sounds and earthquakes. One of the researchers said they believe the noises are happening in the air, not underground. The team looked at infrasounds, which are low-frequency noises that humans can't hear. They found signals lasting 1 to 10 seconds that matched the times when people reported hearing the booms, but nothing is certain here. Some people think that solar flares, underwater tsunamis, or caves collapsing under the sea cause skyquakes. Others believe the sounds come from planes making loud sonic booms. But that doesn't explain old records of skyquakes from the past before planes were even invented. Some scientists think a type of meteor called a bolide causes these booms. These meteors blow up when they hit Earth's atmosphere. If this happened above thick clouds, the sound would get louder and travel far, but we wouldn't find anything on the ground. Another idea is that gas might be escaping from the bottom of deep lakes, like Lake Seneca. If you think skyquakes are bizarre, let me introduce you to fog bows. They also go under the name of white rainbows, ghost rainbows, or cloud bows. They form in a similar way to regular colorful rainbows, but are much wider. Rainbows happen when there are big raindrops in the sky, and you can always spot them on the opposite side of where the sun is shining. Fog bows are made by tiny droplets in fog, or clouds, instead of big raindrops, and they also appear opposite the sun. If you want to see a fog bow, you need to look for it in a thin fog when the sun is bright. You might catch one when the sun starts to shine through the fog, or if you're near the ocean where fog often forms. Because the water droplets in fog are so tiny, Fog bows don't have bright colors like rainbows. They might even look all white or just have faint colors. Some fog bows are hard to see at first because they blend into the mist, but once you spot them, they're easy to recognize. The next rare weather phenomenon you gotta watch out for is thunder snow. You guessed it right, it's a special type of thunderstorm that happens during a snowstorm. Unlike regular thunderstorms that often strike in the spring and summer, thunder snow is much rarer because it happens in the strongest winter storms, like big blizzards, and at the same time needs warm air, which isn't a frequent combo. So, for thunder snow to happen, there needs to be moisture in the air, some instability, and something to lift the air like rising winds. Just like in normal thunderstorms, lightning can appear when you hear thunder. Thunder snow lightning usually goes from cloud to cloud instead of hitting the ground, and the thunder sounds different too, more like a low rumble instead of a loud boom, because the snow muffles the sound. You aren't so likely to get struck by it, but it's still important to stay inside when you hear thunder to stay safe. Northern Lights fans, this one is for you. Scientists noticed a new kind of glow in the sky that looked like a purple streak. They nicknamed it Steve as a joke, but later gave it a more scientific name: Strong Thermal Emission Velocity Enhancement, Steve for short. Steve is actually a fast-moving stream of super hot gas that always moves west and only shows up before midnight. They wondered if something like Steve could happen after midnight, but moving in the opposite direction. And now, scientists think they found the anti-Steve by looking at data from a research station in Norway. In December 2021, they took a picture of a bright purple streak stretching for 620 miles in the sky, and it only appeared after midnight. Satellites from the European Space Agency also measured the conditions in this part of the sky and found that the ions were moving eastward. Steve's late-night twin hasn't been officially named yet, but it would be cool if it was called SAM, which is short for Steve after midnight. If you've ever seen snow on a sunny day when falling from the sky without a single cloud, it must have been diamond dust. It's a special kind of weather with millions of tiny ice crystals forming close to the ground. These ice crystals float slowly in the air, kind of like how dust floats in your house. When sunlight hits these crystals, they sparkle like diamonds. Unlike regular snow, diamond dust can fall from a cloudless sky, which is why they sometimes call it clear sky precipitation. It happens because of temperature inversion. Normally, it gets colder as you go higher up from the ground, but in a temperature inversion, the cold air stays near the ground and warmer air sits above it. The warm air has more water vapor, and when it mixes with cold air near the ground, it turns directly into ice crystals, and diamond dust is born. For this to happen, the air near the ground has to be really, really cold, way below freezing temperature. Diamond dust can fall for days, but it's so light that it usually doesn't pile up on the ground like regular snow. A fall streak hole, also known as a hole punch cloud, is next on our list. This big circular or oval-shaped gap sometimes appears in certain clouds. These types of clouds float high up in the sky and are often made of tiny water droplets that are colder than freezing, but they haven't frozen yet. These special water droplets are called supercooled, and they need a reason to freeze. Ice crystals give them that reason. When a plane flies through the cloud, it can bring those ice crystals into the cloud. Once the ice crystals are there, the supercooled water droplets freeze quickly, get bigger, and start to fall from the ground. This creates a hole in the cloud, and as more nearby droplets freeze, the hole gets bigger and spreads outward. Any tornado is scary, but a fire tornado takes the horror to a new level. These bad boys are spinning towers of flame and ash that form when there's extreme heat, strong winds, and uneven ground. The intense heat from the fire causes hot air to rise quickly. Cooler air from the sides rushes in to replace it and creates strong winds. When winds from different directions meet, It makes the fire spin like a tornado. It gets stronger and can even create its own weather. It pulls in flames, ash, dirt, and anything in its path. The winds can reach speeds of over 140 miles per hour, and these fire tornadoes can last for more than 20 minutes.
Let me take you to a place that seems to be out of this world. Life inside this cave has been isolated from the outside world for about 5.5 million years, and it does show. See for yourself. Due to such a long isolation, the conditions inside the Mobile Cave are like nowhere else on our planet. A unique ecosystem is flourishing there, even though there is a severe lack of sunlight inside the cave, and the air is toxic. The cave, located a few miles west of the Black Sea in Romania, was first discovered in 1986. Nowadays, you can only visit it if you have special permission. Plus, the central caverns are guarded naturally by narrow limestone tunnels and vertical shafts. So, if you're no stranger to claustrophobia, you'd probably better not enter this place. In the depth of the cave, the air has twice less oxygen than the air outside. Instead, it contains a lot of carbon dioxide and hydrogen sulfide, so not the freshest air you can breathe. It's also pitch black inside the cavern. But despite, or should I say thanks to, this cocktail of extremely harsh conditions, the site is a true goldmine for biologists. Shockingly, life seems to be booming here. In a 1996 study, scientists identified 48 species, and 33 of them were unique to the cave. Most of the creatures inhabiting the cave are tiny, with long limbs and antennae that help them navigate in the dark. They have no vision and lack pigment, and it makes sense. Why would you need to be able to see if you live in total darkness? And why would you need to be pretty and colorful with no one to see you? Now, I'm going to take you to another cave. It's no less amazing, but looks very different. This is the Giant Crystal Cave, aka the Cave of the Crystals, in Mexico. These ginormous crystals were found in 2000 by a mining company after the water was pumped out of the cave. Two miners then saw the crystals after entering the drying cave on foot. These awe-inspiring crystals are actually massive gypsum pillars hidden 984 feet underground. They're anchored to the walls and the floor of the scorching hot cave. Scientists estimate that the crystals could have been already growing for 500,000 years. That's why many of them are so long and wide that you can walk across them. Unfortunately, visiting this wonder of nature is impossible at the moment. But maybe it's for the better, since the Giant Crystal Cave is a dangerous place that can easily turn into a trap. For tens of thousands of years, it was filled with groundwater, which was originally pushed upward into the opening by a magma chamber located in the depths of our planet. The magma under the cave kept the water hot, but eventually the temperature of the water dipped below 136 degrees Fahrenheit. As a result, the water started to fill with calcium and sulfate, whose particles began to recombine into gypsum. And then, white-tinted crystals took over the cave. And since they stayed underwater, they were able to keep growing. You don't have to fly to space to take a closer look at a black hole. Scientists have found something very similar to black holes in the southern Atlantic Ocean. A black hole has such an enormous gravitational pull that once something gets pulled inside, it doesn't have any chance to escape. Even light can't get out of a black hole. But ocean black holes seem to be almost as powerful as their space relatives. But instead of catching the light, they do the same with water. Ocean eddies are massive whirlpools that spin against the main current. They usually swirl billions of tons of water, and most of them are larger than a city. These whirlpools are so powerful that nothing trapped by them can escape. But the scariest thing is that you might not even notice heading into one of them. These things are so huge that you won't spot their boundaries until it's too late. When scientists started exploring ocean vortices with the help of satellites, they discovered the borders of several eddies. After that, they managed to prove that, mathematically, these whirlpools are the same as mysterious black holes in space. Massive eddies are surrounded by super-tight barriers where fluid moves in closed loops. Even water can't get out from the inside of these loops. That's why tight ocean vortices play the role of enormous containers. Water inside them can be totally different from the ocean surrounding an eddy. And I'm not only talking about its temperature. The salt content inside and outside a whirlpool often differs as well. On the thin Curonian spit splitting the Baltic Sea from the Curonian Lagoon, there is one of the most bizarre places on Earth. Locals call this area the Dancing Forest because pine trees in this forest have shockingly unusual shapes. They twist in spirals and circles along the ground. There are some theories why it could be happening, of course. Some people claim that huge amounts of positive and negative energies once clashed in that spot. More down-to-earth individuals believe that the reason is geological. Sandy soil in the area is too unstable to hold trees growing upright. The most popular is the idea that strong winds blowing from the water influence the shape of the trees. In any case, experts haven't come to the final conclusion yet. Look at these underwater crop circles. For the first time, they were spotted in 1995, close to southern Japan's coast. Local divers called these 7 feet wide structures mystery circles. The enigma had been plaguing many minds for almost 16 years until the culprit was finally caught. Imagine the researchers' surprise when it turned out to be a male pufferfish. The fish needs a bit more than a week to build one circle, and the aesthetics are obviously crucial. A male is swimming inside the circle, digging valleys in the sand with its fins. But that's not all. The fish also use shells and corals to decorate particular parts of their circles. This whole build-a-circle thing has a practical purpose as well. The way a male fish swims pushes the sand toward the center of the circle and creates a mound which later serves as a nest. The next mystery on our list is in the Caribbean. Just off the coast of Belize, there's a giant sinkhole. That's the Great Blue Hole. It's about 1,000 feet across and more than 400 feet deep. Once, a long time ago, this hole was a cave. But then rising waters filled it, making it collapse in on itself. The deeper you'll descend into the Great Hole's crystalline waters, the darker it will become. You'll see tons of stalactite-filled caves there, but entering them is extremely dangerous, unless you want to get hopelessly lost. Once you reach a depth of 50 feet, you'll notice that the water is shimmering. That's the invisible line dividing the sinkhole's salty top from the freshwater abyss. You might want to turn back right now. Who knows what you might come across in the murky depths. There was an old Amazonian legend that told about the river that was so hot that it boiled. And it was believed to be just a legend until Peruvian geoscientist Andres Russo questioned if the river could be real. All experts denied such a possibility. After all, hot rivers do exist, but only in the areas where there are volcanoes. As for the part of the country mentioned in the legend, there are no volcanoes in that region. But Andres Russo was too dedicated to give up. And in 2011, he finally located the river from the legends. The water in it was indeed steaming hot. Its temperature was 186 degrees Fahrenheit, not boiling, but pretty close to this point. But what shocked the researcher the most was the size of the river. One could think that the almost boiling water was the result of the activity of an underwater hot spring. But thermal pools are always small, while the river is 20 feet deep and flows for almost 4 miles. This is the only river of its kind on our planet.
The largest volcanic region on Earth is not in Africa or Japan, but under the ice of Antarctica. Scientists found 138 volcanoes in its western part, and if they decide to go wild, you'll surely notice it. They could melt huge amounts of ice that will move into the ocean, raise its level, and make our planet uninhabitable for humans. But before you pack your things to fly away to another planet, hear me out. Only 2 of the Antarctic volcanoes are officially classified as active now. And it would take a whole series of eruptions, decade after decade, to seriously impact the whole world. Mount Erebus, one of the 2 Antarctic volcanoes currently in action, proudly bears the title of the world's southernmost active one. It has been continuously erupting since at least 1972. It emits plumes of gas and steam and sometimes even spews out rocks, and scientists call it Strombolian eruptions. One of the coolest features is a lava lake in one of its summit craters, with molten material on the surface. Such lakes are rather rare because they need certain conditions to make sure the surface never freezes over. The second active volcano is Deception Island, a horseshoe-shaped landmass. It is the caldera of an active volcano that last erupted over 50 years ago. Scientists who monitor it say it shouldn't go wild anytime soon. Antarctica also has plenty of fumaroles. Those are volcanic vents that release gases and vapors into the air. In the right conditions, they can spew out enough stuff to build fumarolic ice towers up to 10 feet tall. Scientists keep an eye on the Antarctic volcanoes with seismometers that detect when the Earth starts trembling from volcanic activity. Sometimes they also use more complicated tech, but it's all really challenging because of how far away this polar region is and how tricky it is to get there. That's why no one can predict when one of the continent's volcanoes that are now sleeping might erupt. We can guess what this waking up would look like if we analyze the events from nearly 20,000 years ago. So, shall we? One of Antarctica's sleeping volcanoes, Mount Takahe, had a series of eruptions and spewed out a good amount of halogens rich in ozone back then. Some scientists say these events warmed up the southern hemisphere. Glaciers started to melt and help finish the last ice age. For these events to repeat, we'd need a series of eruptions with substances rich in halogens from one or more volcanoes that are now above the ice. It's an unlikely scenario, but since it already happened in the past, it's not completely impossible. As for volcanoes hiding under a thick layer of ice, it looks like their gases would hardly make it to the atmosphere, but they would be strong enough to melt huge caverns in the base of the ice and produce a serious amount of meltwater. The West Antarctic ice sheet is wet and not frozen to its bed, so this meltwater would work as a lubricant and set the overlying ice into motion soon. The volume of water that even a large volcano would generate in this way is nothing compared to the volume of ice beneath it. So, a single eruption wouldn't make a difference. But several volcanoes erupting close to or beneath any of the western Antarctica's big ice streams would. Those ice streams are rivers of ice that take most of the frozen water in Antarctica into the ocean. If they change their speed and bring unusual amounts of water into the ocean, its level will rise. As the ice would get thinner and thinner, there would be more and more new eruptions. Scientists call it a runaway effect. Something like that happened in Iceland. The number of volcanic eruptions went up when glaciers started to recede at the end of the last ice age. So, it looks like, for massive changes, several powerful volcanoes above the ice with gases full of halogens need to get active within a few decades of each other and stay strong over many tens to hundreds of years. Antarctica stores around 80% of all the fresh water in the world, and if they melted all of it, global sea levels would rise by almost 200 feet. And then we'd have to look for a new planet to live on. But this again is an unlikely scenario. It's more likely that the eruptions under the ice will lubricate ice streams and seep water into the ocean. But it wouldn't be the end of the world. A super strong, super angry supervolcano could do it though, and it has already happened in the past. Over 200 million years ago, the world went through a major makeover with not one, not two, but 4 massive volcanic eruptions in huge pulses. The supervolcano called Camp had been erupting over and over for 600,000 years. It all happened in Wrangell, a large chunk of land that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. And it wasn't the lava or the volcanic ash that ruined the environment. The eruption made carbon levels skyrocket. The planet would never be the same again. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in Asia to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels. It made the atmosphere toasty, and the rain poured down. So the bad news is, another eruption like this could happen. The supervolcano beneath Yellowstone National Park has been sleeping for nearly 70,000 years. But if it wakes up, it would be many times more catastrophic than the eruption of Mount St. Helens in 1980. It's considered the most disastrous volcanic eruption in U.S. history. It followed 2 months of earthquakes and injection of magma below the volcano that weakened and destroyed the entire north face of the mountain. The eruption column went 80,000 feet into the atmosphere and spread ash over 11 U.S. states and several Canadian provinces. The last Yellowstone eruption was 1,000 times greater than that. The ground above Yellowstone sits on a hot spot made of molten and semi-molten rock called magma. This magma stuff flows into a chamber beneath the park, about 4 to 6 miles down, making the ground puff up like a balloon. But then, as it cools down, the ground goes back to its usual state. Volcano watchers have been keeping an eye on this for a century. They noticed the ground lift up about 10 inches around 20 years ago, but since 2010, it's been going back down. The experts say we have no big eruptions on the horizon, so doomsday isn't coming anytime soon. But there's some underground activity going on lately which keeps us interested. Since humans haven't been around to witness every little thing Yellowstone does, it's kind of tough to say for sure what's brewing down there. Yellowstone has had some epic eruptions within the last couple million years. They happen like clockwork, with gaps of 600,000 to 800,000 years between them. The last big one was around 640,000 years ago, and it basically reshaped the entire landscape, spreading ash and debris as far as Louisiana. You can still see the aftermath of the last big eruption in the Yellowstone caldera today. Experts say a massive eruption like the last one is an unlikely scenario. We're more likely to see eruptions of steam and hot water or lava flows. When and with what force it will wake up remains a mystery to scientists.
Fraser Island sits off the coast of sunny Queensland, Australia. But don't fall for its beauty. It's home to the most dangerous beach in the world. There's nowhere on the island to seek medical attention. If you do run into danger, you're on your own. Dingo attacks are super common here. If you don't know what a dingo is, it looks like an adorable dog. But beware, this wild breed is extremely dangerous. And the dingo's gnashing teeth aren't the only thing to be scared of. The seas around the island are swimming with great white sharks. There's jellyfish in the water too. Fraser Island is home to some of the world's most dangerous kinds, including the Portuguese bluebottle. One sting from its venomous tentacle is enough to take down an adult human. Even if you manage to avoid the creatures on the island, the sea itself is perilous. The waters are incredibly rough and have powerful riptides. These are strong currents that will pull you away from the shore. And remember, there are no lifeguards to come to your rescue if you get in trouble. Even the sand is dangerous. Car rollovers in the thick dunes happen all the time. It's definitely best to swap your car for a dune buggy. Travelers also often drive down the dunes straight into the lakes below, but the lakes are incredibly shallow, which is not very safe. Fraser Island is also known for its beautiful lookout points, but you'll need to watch your step. You might feel on top of the world, but stay well away from the edges as jagged rocks and crashing waves line the shore below. There's an island in Brazil known as Snake Island, which is equally dangerous. I wonder what the hazard could be here. It's home to thousands of golden lancehead vipers, which are one of the most venomous snakes on the planet. They grow to over 20 inches long, and their fast-acting venom melts the flesh from around their bites. There are around 4,000 snakes on the tiny 106-acre isle. Snake Island has become so dangerous that the Brazilian authorities had to ban everyone from going there. For years, the only human inhabitants to brave the island were a lighthouse keeper and his family. But local legend says that one night a group of snakes crawled in through a window to attack, and the family was never seen again. Known as the Gas Mask Town, the island of Miyake-jima is not one to visit in a hurry. It's home to a fiery, active volcano that has erupted several times over the past few years. There were several massive eruptions leading to the spread of a highly poisonous gas across the island. Residents are now required to carry gas masks at all times, and a terrifying alarm blares across the island whenever the poison levels get too high. The island is also in the middle of the Devil's Sea. Ships mysteriously vanish in the area, and experts have no idea why. The North Sentinel Island is home to a remote and unwelcoming tribe. They lived alone on the island without any modern technology or contact with the outside world for over 60,000 years. And that's just the way they like it. They've been known to fire arrows at anyone who attempts to enter the island. There are many stories of people visiting the island, and they are never seen again. It's not ghoulish ghosts or slithering snakes that you have to worry about on the Caribbean island of Saba, it's hurricanes. The tiny island has been hit by more severe hurricanes than anywhere in the world over the last 150 years. There have even been 7 tropical cyclones, which is an intense circular storm. The winds in these storms can reach 254 kilometers an hour. Try standing up in that. You'll also struggle to find a pilot who'll even land on the island. It's incredibly dangerous not because of the winds, but because it's home to the shortest runway in the world. It's only 440 yards long. 2 huge rocky ridges surround the runway, so there's no room for mistakes. The Kilauea beaches of Hawaii used to be one of the most dangerous in the world. The Kilauea volcano has been almost consistently erupting for the past 35 years, spewing red-hot lava into the surrounding waters. The water temperatures have even passed boiling point as a result of the lava. Happily, it's no longer active. While the island of Bikini Atoll might sound like the perfect summer vacation destination, it's most certainly not. The problem is that this place has dangerously high radiation levels, and the locals had to leave it. Although the island was declared safe in the 90s, its original inhabitants have refused to return. The lack of fishing in the area has also led to a massive increase in sharks who swim the waters in search of their next meal. Strangely, the corals and reefs are thriving. From the distance, Ramree Island looks idyllic. White sand, swaying palms. But beware. They say thousands of hungry saltwater crocodiles used to lurk there, ready to strike at any time. The exact number of those animals was unknown, and some scientists claim that there are quite a few of them right now. I'd stay well clear of the island though. I don't really feel like becoming crocodile food. Skeleton Coast in Namibia is appropriately named as the harsh landscape and lack of water make life almost impossible. Whale carcasses, turtle shells, and elephant rib cages litter the shore. If that isn't bad enough, lions and hyenas patrol the beach in search of their next meal. The surrounding waters are just as dangerous, as they are home to 11 different species of shark. Many sailors have become lost on this coast and have never been seen again. Cape Tribulation in Australia also lives up to its name as it is packed, full of dangers. Swimmers have to wear special stinger suits because the water is teeming with stinging jellyfish. Saltwater crocodiles also hide in the water, but they don't make a suit to keep you safe from those. It's not just the jellyfish that sting. The area is covered in stinging trees. The trees have jagged leaves that give the crocs' teeth a run for their money. On land, there's angry cassowary birds. There are flightless birds that are the same size as an ostrich. They have sharp talons that can easily slice through skin. The Utterkleiv beach in Norway is one of the best places to see the northern lights, but you'll be lucky if you survive more than one night there. The seas surrounding the island can reach 46 degrees Fahrenheit, and that's just in the summer. It probably feels like swimming in ice cream. For years, Gansby Beach has remained a habitat for the most dangerous creatures on the planet. Sharks are particular fans of its waters, and the coastal stretch is known as the Great White Shark Capital. The sharks are attracted to the 60,000 sea lions that flock to the beach every year. Not just shark food, wild sea lions can be unpredictable and aggressive towards humans. Comoro Islands are the worst vacation destination for those who don't really like mosquitoes. The place is swarming with the little guys. Locals say all the water on the island must be contaminated because of them. So they like to sterilize water before drinking, making ice, and even brushing their teeth. If you're really into coconuts, there's one place you should probably go to grab some. I'm talking Danger Island. Yep, it's the real name of one of the islands in the Chagos archipelago. It shouldn't scare you off though. The major problem it has is parking. I mean, safe anchorage for those who come there. Finally, while it may sound dreamy, you're probably going to want to avoid the beaches of the Amazon. Sharp-toothed red-bellied piranhas, anacondas, and electric eels are just some of the beach's regular residents. It has one of the widest varieties of animal species on the planet, including the Amazonian giant centipede, which has a poisonous bite. It's not just the animals of the Amazon that you have to watch out for. Strychnos and curare are the two Amazonian plants that are super poisonous.
One of the few places you haven't traveled to yet is a volcano. It's an opening in the Earth's crust through which hot gases, molten rock, and other stuff get to the surface of the planet. But which one should you choose? There are different kinds of them. For example, shield volcanoes are built almost entirely of solidified lava flows, or lava domes formed by small masses of lava that are too thick to travel great distances. You can also pick a cinder cone. It's the simplest kind of volcano out there. It's built from blobs of almost solid lava that erupts from a single vent. This lava is ejected into the air with great force. Then it breaks into tiny fragments that become solid and fall back as cinders. With time, they form an oval or circular cone around the vent. Such cones rarely rise more than 1,000 feet. But what if you choose something even more impressive? How about traveling down a stratovolcano? Huge, steep-sided, and powerful. Once you've made your choice, you also decide to opt for an active volcano that is erupting at this very moment. What you're observing now is called a glowing avalanche. The volcano has just erupted a huge portion of lava, which has created a pyroclastic flow. Its temperature can reach an insane 1,300 degrees Fahrenheit. You see how this flow gets formed from rock fragments and surges down the flank of the volcano at a speed of several hundred miles per hour. Ash is raining down on Earth like grayish, powdery snow. Volcanic ash consists of tiny particles of pulverized rock, volcanic glass, and minerals. When the ash gets mixed with the water from mountain streams and rivers, raging mud flows appear. Despite how scary it all looks, you get closer. Good thing you're wearing a protective suit that can withstand any temperature. The nearer you get, the more fumaroles you spot. These are holes and cracks at the base of the volcano and in its slopes. They emit huge clouds of steam and volcanic gases, carbon dioxide and sulfur dioxide. Some of the cracks are so large, you can probably squeeze through and sneak a peek inside the volcano. But you have a different destination, the crater. On your way there, you spot a strange conical structure on the side of the volcano. It looks like a horn growing on the main cone. It must be a secondary cone, also known as a parasitic cone. Such cones form around secondary vents that reach the surface of large volcanoes. In this case, an eruption can occur not only through the main vent at the top of the volcano, but also through these additional vents. In any case, that's not where you're heading. Soon, you reach the crater. It's a massive circular basin. When you go to its edge and look inside, you see it's also very deep. The lava vent, which is where you need to go, is at the bottom of the crater. But even before jumping into the vent, you spot some strange tubes hiding under the lava flow. Those are lava tubes, natural passages through which fresh liquid lava travels beneath the surface of the lava flow. You decide to make a detour and follow one of the tunnels. It's the main lava tube. You also spot several smaller tubes. They supply lava to one or more lava flows. If the volcano wasn't erupting at the moment, the lava would drain downslope from this tube system. The passages would have lava marks on the walls, a flat floor, and lava stalactites hanging from the ceiling. But even now, there's some empty space above the flowing lava. That's because it has eroded downward, making the tube deeper. But right now, you need to get back. You take the next turn and get back to the crater. You wait till the volcano spews another portion of boiling lava and dive into the volcano's throat. It's the entrance of the volcano. Lava and volcanic ash get ejected from here. The volcano's throat is wide, and you easily travel deeper down. The lava around you glows bright red and orange. That's because when it first bursts to the surface, its temperature can reach 2,200 degrees Fahrenheit. That's hot enough to melt iron. You move down the volcano's main vent. It's a weak point in our planet's crust. There, scorching hot magma manages to escape from its chamber and reach the surface. While going deeper and deeper into the vent, you notice sills. Sometimes, lava intrudes between the crack in the crust, pools there, and crystallizes. This creates deposits of ash and solidified lava. That's what sills are. Pretty soon, you reach a magma chamber. It's a large pool of molten rock. The one you're in at the moment is quite shallow. That's because it's not the main one. After traveling several more miles down through the vent, you get to another huge magma chamber. It supplies the small one beneath the base of the volcano. The main magma chamber lies in Earth's crust, which stretches from 3 to 44 miles deep. The molten rock there remains under extreme pressure, and the temperatures inside are incredibly high. With time, the rock surrounding the magma chamber starts to break and fracture. This creates outlets for the magma, and since it's made of a much less dense material than the surrounding rock, the magma begins to seep through the cracks to the surface. From the main chamber, it rises to the upper one. Then it makes its way to the surface in a powerful eruption. You explore the magma chamber and then decide to go even deeper than that, to the place from where all that molten rock gets into the magma chamber. You're moving through the crust. The volcano is located on land. That's why your trip takes longer than it would if you were traveling through the oceanic crust. It's only 3 to 6 miles wide. But the continental crust is much thicker. It can be 28 miles thick in some places. As you're going through the crust, you can't but notice its light color. That's because it consists mostly of granite. If you were going through the oceanic crust, the material surrounding you would be dark or nearly black because it has a different composition. The deeper you go, the hotter it becomes. Sure, the temperature here isn't as high as in the magma chamber, but still, at the boundary with the mantle, your thermometer shows 750 degrees Fahrenheit. At a depth of about 20 miles, you reach the boundary between the crust and the Earth's upper mantle. There, the pressure reaches a mind-boggling 10,000 atmospheres. That's where magma comes from. You could finish your journey and get back to the surface, but your curiosity gets the better of you. You decide to go deeper, all the way to the center of the Earth. The next layer on your way is the mantle. It makes up 2/3 of the Earth's mass and 84% of our planet's volume. It's 1,800 miles thick. The rock closer to the inner part of the mantle is semi-solid, like caramel candy. The upper part of the mantle, as well as the crust, is broken into massive pieces. They look like a colossal jigsaw puzzle. Those are tectonic plates. They drift at a speed of 1 to 2 inches per year. You're moving through the upper mantle and feel the temperatures rising up to 1,600 degrees Fahrenheit. Near the boundary with the core, the temperature is already as high as 7,000 degrees Fahrenheit. The pressure in the lower mantle reaches 240,000 atmospheres. You'd feel the same pressure if 3,300 elephants made a tower on your head. At a depth of about 1,800 miles, you see the boundary between the mantle and the outer core. The insides of the planet around you are heated up to 9,000 degrees Fahrenheit. Such temperature is high enough to keep the outer core liquid. The pressure there is almost 2 million atmospheres, but it's not enough to make the iron that the core is made of solid again. The outer core is 1,500 miles thick. It churns in massive turbulent currents and generates a magnetic field. In the outer core, Earth's magnetic field is 50 times more powerful than at the surface. You are now more than 3,000 miles underground, and you've reached the inner core. It's a solid metal sphere, around 1,500 miles across. The inner core is immensely dense and spins faster than the rest of the planet. The temperature there is as high as on the surface of the sun, 9,800 degrees Fahrenheit. And the pressure inside the inner core is 3 million times greater than on the surface. It took about 500 million years for the inner core to form, which means it's younger than some parts of the crust.